This is Precalculus Lesson 1-2. I'm Mr. Sindel, and I just want to say hello Daisy, hello Rochelle. If it sounds like I'm talking quiet, it's because Riley is trying to sleep in the other room and I don't want to wake him up. And just a note about this lesson too, I don't have my tablet, so my handwriting is going to look pretty terrible. Alright, let's move on to deriving some properties about sine and cosine. So I graphed f of x equals sine of x here for you, and I want you two to graph the graph of y equals 0.4. What does that look like? The constant function. So go ahead and graph it now if you know it, and if you don't know it, hold on here for a few seconds, because 0.4 is going to be this horizontal line that goes through 0.4. Oops, let's move this down a little bit. So it's a horizontal line, like that. And I need to change my drawing mode to a pen, and I also need to snap to a grid. Unfortunately, I can't just type in here because it moves everything else down, so I have to try drawing with my mouse to the best of my ability here. So, oh gosh, he's waking up. Alright, I'll be right back. Alright, well, he's awake, so I can talk louder now. He might be in the background of the video, which will be interesting. So, let's go ahead and label the points where the graph of y equals 0.4 intersects the graph of f of x equals sine of x. So it intersects here, we'll call that point A. Again, I'm drawing with my mouse, I'm sorry. This is point B. Oh gosh, it's so bad, I know. C, and I don't know if we'll need this point, but let's just say it's D. Notice that when we have the sine x function going through the origin, it comes from the bottom left to the top right. Where does that happen again? Where else on this graph does that happen again? It happens over here at negative 2 pi, coming from the bottom left to the top right. It happens over here at 2 pi, coming from the bottom left up to the top right through the x-axis. So this function, sine of x, repeats every 2 pi, and because of that, we can have the following function. I'm going to do radians on the left, I'm going to do degrees on the right, so we'll have both versions, which is this. So if I have sine of theta, so theta is kind of like a circle with a line through it, it should look more like that. Sine of theta, that's the same thing as sine of the same theta. I'm not even going to try to correct my hand drawing, it's going to be bad the whole way through, I'm sure. Sine of theta, but I can add or subtract any amount of 2 pi radians. So I can say plus 2, oh my god, I can't even read that, 2 pi, and you can do that once. You can add 2 pi, you can add 2 pi again, 2 pi again, I can add a negative 2 pi, I can go backwards. So to account for just any multiple of 2 pi, we say 2 pi times an integer n. So we'll say times, it's a little dot, times n. And I need room for degrees. Let's just go ahead and do degrees above this if you want, if you can squeeze that in here. I can do that in black or something. So 2 pi is the same thing as 3, oh come on Mr. Sindel, 360 degrees. That's with 6. That's the only difference in the formula. I would have liked to write it over here on the right hand side twice, but that's all I've got. Now let's look at point A. So this distance right here is theta. A is theta away from x equals 0. So here's x equals 0, and if I move theta in the right direction, the positive theta, I now get to the x coordinate of A. Now let's look at B in comparison to pi. So here's pi, and then B went over this amount. This amount right here that B went to the left is also theta. It's kind of a cool property of sine. And it's actually, since I went positive direction over here and I went negative direction over here, I'm going to call this negative theta. But look, it has like this symmetry in it, where if I reflect it over this line pi over 2, or if I think about it, its distance from 0, or its different distance from pi, I can speak, then you can get to the same point, and that creates a new symmetry, which we will do in green again, which is this. I'm going to try to draw a smaller sine of theta is the same thing as sine of, and then we basically need to say this theta right here, and I have to go 2 pi, I have to go to the position pi and then backwards theta. So sine of pi, you just add on another pi, but then you go backwards theta, minus theta. And now I have enough room for doing it in degrees. And that's in degrees, it's the formula sine of theta is equal to sine, and the only difference here is the pi changes to degrees. So pi in degrees, this is 180 degrees, so it's 180, oh, forgot the 0, 180 degrees, and then minus theta again, minus theta. So now we have both those formulas. Alright, let's take another look at some other points over here. So this is the main formula that you need to memorize, this one right here. If I had to star anything in my red pen, then I would say this formula right here I would want to star. That's probably a big dude from this lesson. But if I come and look over here, this C is also, this distance right here is also a theta. It's actually a negative theta, so it's moving in the left from pi. Because, so we already know that A is, the x-coordinate of A is theta away from 0. We already know this one. And let's look at pi over here. So this is actually negative pi. If I go negative pi and then minus theta again, I get to the same height. All of these are showing how to get to the same height that we found over here in A. So we can actually come down here and make a new formula, and this one is used a little bit less often in Khan Academy, but it's just kind of nice to have it. I would not star this one, which is this, sine of theta. So this is the height. This right here corresponds to this height at A. This is A. That's the same height as sine of where else? Well, we went minus pi and another minus theta. So sine of minus pi radians minus theta. And in degrees, I know, Riley. And in degrees, that's sine of negative 180 degrees. Negative 180, I know it's bad. Negative 180 minus theta. Cool, so now we have all three of these formulas, and all these are going, well, at least the first two are going to be used over and over again with Khan Academy. Let's look at cosine now. So cosine, I graphed it here for you. Let's again graph y equals 0.4. I hope that you should be able to do this now that you've seen it once before. So I'm going to go to green, make a line. I also want it to not snap to the grid, unsnap. So 0.4 looks like this. Close enough. I know it. Okay, it's going to bother me. Let's see if I can get it more horizontal. That looks better. And then I have to go back here, unsnap to the grid, or yeah, resnap to the grid, and let's go ahead and again mark those some points here. So this is going to be A, and this is going to be B, and that's all I really care about for this one. All right, so we know that this function also repeats every 2 pi, just like sine. So if I take a look at this height of 1, that height of 1 happens at 0. What's the next x-coordinate? This 0. What's the next x-coordinate where I get a height of 1? Well, I get a height of 1 over here at 2 pi. I also get a height of 1 over at negative 2 pi. So every 2 pi, I get back to the same height. This function repeats every 2 pi. It's going to be very similar to the formula up here, where I have cosine of theta equals cosine of theta plus 2 pi times n. And 360 is the same thing as 2 pi. So let's try to write in that. So cosine, I should be doing this in green. I kind of match what I have up there. So cosine, Riley's trying to get into the cat food. Cosine of theta, oh gosh, theta, better-ish, is the same thing as cosine of the same theta, but 360 away. So plus 300 and, oh wait, it's not, we're not doing radians yet, sorry, so, or we're not doing degrees, we're doing radians. So plus 2 pi. And in degrees, I actually have enough room, so I'm going to do it. In degrees, that formula looks like, I want to do black, there we go. Cosine of theta is equal to, you can't even read this. Listen to what I'm saying. What I'm saying is what you need to write. Is equal to cosine of the same theta, but instead of 2 pi, it's in degrees, so it's now going to be plus 360. Ooh, and there is a teacher error. See if you can catch this. What's the difference between this line and the other line aside from the cosine? Hey Randy, what's going on? You and Mr. Lion? It's Mr. Lion. There you go. Yeah, the error was there should be an n here because it's not just once 360 that you can add. You can add any multiple of 360. I can add 720, which is 2 times 360, and I'll get to the same height. So it's any multiple, any integer multiple of 360. So this should be 360 degrees times n. And over here, Riley, where'd Mr. Lion go? This should be times n as well. I'll be right back. And I'm back. All right, so let's go ahead and analyze how far away a, the x-coordinate of a, is from 0. So this distance right here, and maybe I should switch. Whoa, why did it move down there? That's weird. Notice that this distance right here is also theta. It's a little bit bigger, now it's a cosine function. But that giant distance theta is the same distance over here, just in the other direction. So I'm going to call this negative theta. And I consider this to be an easier rule than the sine rule because it's just usually one of them. Khan Academy uses the same one over and over, and I would use the same one over and over even without Khan Academy as well. So let's do the one on the left is going to be our cosine. So if we have cosine of theta, so the height at cosine of theta, so this height of A is the same height over here at B, and how do I get to B? I do this. I do cosine of negative theta. And this rule works because this function is even. Even just means if I had this on a piece of paper and folded it across this line y, the y-axis, then the line of the function would match up on both sides. And let's do the degrees one. So cosine. Oh, actually, this is the degrees one also because there's no radians or degrees. So it's this rule works for both of them. Let's move to the second page. So this is going to be on the back of your piece of paper, hopefully if everything went according to plan. Alright, so we have two examples. Both of them are taken from Khan Academy. So I need to select one or more expressions. So there might be multiple answers. Notice it says choose all answers. I can select 5, I can select 1. Solutions to the equation. Your answer should be in degrees. So if I'm in degrees, that's important. I'm not in radians. Alright, so we're also assuming that n is any integer, just like we did above, and we have the following statement, this following equation. Sine of x equals negative 0.7. We need to solve for x, essentially. To solve for x, to get rid of the sign, we're taking the arc sine of both sides. So I'm taking arc sine, or sine to the negative 1 of the left-hand side, and sine to the negative 1 of this side. So x will be equal to arc sine of negative 0.7. What is arc sine of negative 0.7? Let's figure that out. So this is going to be arc sine of negative 0.7, and that is negative 44.43. So this is going to be negative 44.43. And remember that we can always use this rule up here where you can add 2 pi n, or add on 360 degrees. So go ahead and say that you can always add 300. That's not a 3. 360 degrees times any multiple. So I can add 360, I can subtract 360, I can add 720, etc., etc. And you can already see that is exactly one of these answers. That's B. Alright, so let's use another rule. We can use either of these two rules. Technically, both these rules are the same thing because if I add, for example, if I add 360 to this number, 360 minus 180 is 180, and I still have the negative theta. So they're really the same rule. The difference is just 2 pi n, or 360 degrees between them. So I'm going to use this first rule, the starred rule. It's the easier one to remember. So I'm going to do x is also equal to, so it's going to be 180 minus theta. And again, theta is this negative 44.43. Trying to pull out that drawer? So minus theta. Hold on, I'll be right back. So I'm going to subtract the negative 44.43. This whole thing is my new theta that I can use, my new starting value, and I can always add any value of 360 degrees times n. And when we simplify 180 minus 44.45, or the double negative, these both turn into, turn into pluses. So what is 180? Oh, I'm in a, yeah, 180 plus 44.45. That should be 224.45. So 224.45 plus 360n. And that is an answer, but it's not in here, so we don't have to worry about that. So again, you don't actually have to memorize this third rule. The way to get to this third rule, and you do have to just check it every single time, is just subtract 360 degrees from here. Remember, this integer n, what if n was -1? Then this would be minus 360 degrees. So let's do 224.45 minus 360 degrees. And I don't trust myself to do this in my head, so I'm just going to use my calculator. So it's going to be, what was the problem again? 224.43 minus 360, and that's going to be negative 135.57. Negative 135.5, did I round that right? 0.57. And then again, plus 360 degrees n. And oh, hey, look at that. That is an answer right here. And that's really all that I can do, because I've gone through all the values. There's not like a negative 1,000 that I need to check. I don't need to subtract 360 to get out there. This one is incorrect because it's 180 degrees. Remember, cosine and sine are both just 360 degrees. This one is incorrect because that's wrong angle, and wrong number to multiply. Yeah, so none of these are correct. It's just A and B. That would be the answer. And we can actually check this too with Desmos. So if I come over here, just get rid of all this stuff. If I graph sine, and I graph y equals negative 0.7, very similar to what we did for the beginning of our notes, I should be able to see that the first point closest to the 0 is negative 44.27. On the other side of this, if I went positive direction, I got 224. And remember, 224, that was the number we got for our second value. What's the other value that we can get? Let's come back over here. That value is negative 135. That's negative 135. It gave us all three of these starting values, and you can always add 360 degrees to all of these to keep getting future answers. 360 degrees for this one happens to be the same exact spot here, and that's why we were able to subtract 360 to get that answer. Let's do example 2. Whoa. Yeah, so example 2. Now it's a different type of problem. We have this interval 270 degrees to 810 degrees. Again, we're in degrees. We haven't done a radian problem yet, but I think it's as simple as going to your calculator, going to this calculator, coming over here and hitting radians and doing all the graphing in radians. The step would be pi over 2. You can go from like negative 4 pi to 4 pi, and same y-axis. But yeah, so let's go ahead and solve this one. Cosine of x is equal to 1, so we're going to take the arc cosine both sides. Cosine to the negative 1 at the left. Cosine to the negative 1. Okay, I mean, it's supposed to be cosine negative 1. You can't even see that. But it should be cosine to the negative 1, arc cosine of both sides. So what is arc cosine of 1 in degrees? Let's come over here. What is arc cosine of 1 in degrees? 0. It's a little bit hard to see, but it's 0. Why does that make sense? If I do cosine and I come over here to 1, notice that at 1, the x value is 0. Again, the arc cosine function just takes in a value of the height. What is the height? The height is 1. It outputs the x coordinate. X coordinate is 0. So we're going to come over here and say, okay, well, the answer is 0 plus 360 degrees. It would have been 2 pi if it was in radians, times n. And okay, so now we actually have to plug in values of n. For values of n, I can plug in negative 1, negative 2. None of these are negative though, so I'm just going to plug in positive values. I'm going to plug in 1, 2, and 3 and see what happens. Uh-oh. Alright, I'll be right back. And now that I'm coming back to look at this, we also want to plug in 0. 0 is technically an integer as well. So if I plug in 0 to n, 0 times 360 is 0. 0 plus 0 is 0. 0 is an answer. So 0, check. Yep, that was an answer. When I plug in 1, 1 is n, so 360 times 1 is 360. 360 plus 0 is 360. Boom, there's our next answer. So 1 worked. When I plug in 2, 2 times 360, that should be 720. 720 plus 0 is 720. Check. 3. If I plug in 3 to 360, that's going to be, carry the 1, that's going to be 1080. Alright, yeah, I mean, it's saying, like, I plug in 3 and it works, right? There's a problem. 1080 is here, it works here, but it's not an answer. Why? It's a trick question. Here it is. This number right here. It gave us a certain interval. We had to choose answers in that interval. While 1080 is, if I took the cosine of 1080, it would be 1. It just happens to not be in the interval. But Mr. Sindel, are 90 and 540 in there? Because don't you have to do the other rule? This rule where you do cosine of theta equals cosine negative theta? Okay, let's try it and see what happens. So if I do cosine, or sorry, I'm not even going to write that down. If I just do this number 0 and do negative 0, it's the same thing as 0. So you can apply this rule, but because cosine of 0 is, or 0 is a peak, you can't really get two answers. And to give you a graphical explanation of what's happening, this is a peak right here. I only have one answer. If I would have moved this down a little bit, then I would have had two answers here and here. Oop, here and not there. Those two answers. But because it came all the way up here to 1, there's only one answer. So that rule, you can apply it, it just won't give you a new answer. And yeah, so that is all of our answers. Let's come back over here to our notes. It's 0, 360, and 720. Oh, and before I go to the summary, I forgot, how do I check those answers? So if you go to Desmos and you graph cosine of x and you graph y equals 1, like I have here, you can actually click on these values and say, okay, yeah, 0, 360, 720 is an answer, 1080 would have been an answer, but it's outside the range. If you want to be like extra fancy, you can enter a range here by going curly brace, which is shift the number right of the p, and you say, what was your left boundary? Our left boundary was 270, so I say 270 is less than x is less than, what was our upper boundary? Our upper boundary was 810, so this is going to be 810, and it actually graphs it for you. So, oh, whoa, okay, so I am totally wrong on this problem. Thank you for checking your work, Mr. Sindel. If I plug in 0, that also doesn't work because 0 is outside of that range as well. I noticed that it didn't intersect up here. I'm like, huh, there's only 2 answers, but we got 3. So this is how you can check your work. You have the correct boundary here. You have the correct function graph. Those are the only 2 answers. So if I come back and click on this, delete, that is actually the answer. So if anyone actually caught that error before I stated it, you guys can get some XP and you get the extra credit point. Just let me know when I'm back in the classroom. Alright, so that is the correct answer. Go ahead and come down here and write your summaries now. Thanks for watching. Bye.